Today our objective is to graph linear functions using function notation. And function notation is just a way to name a function that's defined as an equation. If you look at f of x equals mx plus b, the only thing that's different about this equation in terms of other equations we've looked at is we've replaced y with f of x. Okay? The other definitions we'll talk about tomorrow. So I'm going to go to my blank copy, and we're going to start taking some notes. Okay? So function notation is just a way to name a function. F of x replaces the y. F of x is pronounced f of x. Okay? And what this means is function of x. Okay, write that down. Anytime you need to stop the video, pause it, take notes, please go ahead and do so. Great. Function of x. What this means is y is a function of x, and we've talked about that previously in class. Okay. Y depends on x. And again, function notation is just a way to name a function. So if you look at example 1, it says for the function f of x equals 3x plus 1, find the value of x so that f of x equals 10. What this is telling you, f of x is just replacing the y. So this right here means y equals 10. Okay? And it clearly tells you what they want you to do. So you're finding the value of x. How we do that, right here, this is saying f of x equals 10 or y equals 10. We're going to replace that f of x with a 10. Okay? So we're substituting 10 for the f of x. We're substituting 10 for the y. All right, and then we solve the equation like you solve every other equation. So in the margin, let's write this down. F of x equals mx plus b. F of x is your output. Okay? F of x is your y value. X is your input. Function notation is f of x equals mx plus b. So going back to our original equation, f of x equals 3x plus 1. Find the value of x so that f of x equals 10. We're going to replace the f of x with a 10. Or we're going to replace the y with a 10 and solve for x. Okay, so I'm going to do this just underneath so we can work vertically. 10 equals 3x plus 1. We all know how to solve a two-step equation. We're going to subtract 1 from each side. 9 equals 3x. Divide each side by 3. And x equals 9, okay? So we found the value of x to be 9. So when x equals 3, f of x equals 10. In other words, when x equals 3, y equals 10. So let's look at example 1. For f of x equals 6x minus 6, so find the value of x so that f of x equals 24. Again, the problem is telling you exactly what you're trying to find. F of x equals 24 means y equals 24. So just like we did in the previous problem, we're going to substitute f of x with 24 and solve for x. So go ahead and continue solve problem number 1 and then continue to problem number 2. Pause the video and then when you have finished, start the video so you can check the answer. All right, for number 1, you should have gotten that x equals 5. For number 2, when you substitute 17 into f of x, you get 17 equals 7x plus 3. And when you solve it, x equals 2. I'm sorry. equals 2. Okay? All right, let's continue on to the next page. So actually, before we continue on to the next page, I want you to take a piece of loose leaf out and we're going to take some notes. So pause the video and let's take some notes.
Test, test, test. Test, test, test. Test, test, test.
Okay, sorry for the interruption. On your notes, I want you to put down 4.7 notes, day 1. F of x equals 2, which means y equals 2. And then I want you to write f of 2. So f and then parentheses 2. What that means is x equals 2. We're substituting this x value with a 2. Okay? So when you do that, I'm giving you the x value, which equals 2. So write this down. Given f of x equals 5x minus 3, what is the value of f of 2? Okay? Pause it, write it down, start the video when you're ready. So in this example, what I just gave you was the x value. Okay? 2 is the value of x. If you're given the x value, what that means is you're trying to find the value of the function. You're trying to find the value of f of x. Stating it differently, you're finding the value of y. So what we do, we substitute that value for x into the equation, and we have y equals 5 times 2 minus 3. We could also write that as f of 2 equals 5 times 2 minus 3. I think writing it replaced with a y is probably easier. And we go ahead and evaluate. So y equals 7. Now, to write your answer in function notation, we would write it as f of 2 equals 7. 2 was the value for x you were given. 7 is the value of y that you just found. This example, f of 2 equals 7, is written in function notation. Okay, so if I ask you to write your answer in function notation, this is what I'm looking for. Right, let's try another one. Pause it if you need to. And write this down. Given f of x equals 4x plus 2, what is the value of f of negative 3? Again, what I just gave you, I gave you the x value, f of x, and I'm replacing that x with a negative 3. So with that negative 3, hang on.
Test, test, test. Test, test, test.
Okay, so you're going to replace that x with a negative 3, and then evaluate. 4 times negative 3 is negative 12, plus 2 is negative 10. So y equals negative 10. You're writing your answer in function notation. So function notation is written as f of negative 3 equals negative 10. Okay? Function notation. Your x value is negative 3. Your y value is negative 10. Pause it if you need to. We're going to move on to a third example. Write this down and pause it if you need to. Given f of x equals 1/2 x plus 4, find x when f of x equals 10. So think about what I'm giving you and think about what I'm asking you to find. It's telling you to find x when f of x equals 10. What that means is I gave you the value of the function. I gave you the value of y. You're looking for x. So to find x, we need to replace f of x with 10. Okay, remember this f of x right here is equal to y. So replace y, or f of x, with 10, and now we're going to solve for x. Okay, go ahead and solve. Pause it if you need to. And when you have solved it, you should have gotten x equals 12. All right, again, pause if you need to. We have some more examples. Write this down. What does f of negative 1 equals 3 mean? Right? think about it, pause it, talk to your groups, talk to each other. What does f of negative 1 mean? What this means is negative 1 is our x value, 3 is our y value. Let's write the next one down. Okay, let's stick with this one. So in function notation, that would be f of negative 3 equals 3. F of negative 1 equals 3. Write number 5 down. Pause it if you need to. F of negative 2 equals 3. What does that mean? And when I'm saying what does it mean, what is your ordered pair? What coordinates are we talking about? F of 2 equals 3. It means your ordered pair is 2, 3. X, y. All right, we're going to do one more, and then we'll go back to the note taking guide. So f of 4 equals negative 4. What is the ordered pair? What does this mean? All right, pause it. Your ordered pair is 4, negative 4. Negative y. X, y.
Test.
All right. Let's move on to the note-taking guide. Next page on the note-taking guide, example 2, graphing function. It says, text messages. A wireless communication provider estimates that the number of text messages, m, in millions, sent over several years can be modeled by the function m equals 120t plus 95, where t represents the number of years since 2002. This is a really important point right here. T is the number of years since 2002. So in other words, when t equals 0, this means 0 years since 2002. So think about what year we're talking about right here. Pause it, see if you know what year we're talking about. 0 years since 2002. Talking about 2002. 0 years from 2002 is 2002. When t is 1, that means 1 year since 2002 to 2003. When t is 2, 2 years since 2002 or 2004. And when t is 3, we're talking about 3 years since 2002 or the year 2005. All right? Okay, so we're graphing the function. Go ahead and substitute each of these values for t in the equation and go ahead and evaluate. So do that for a minute, pause it. You're substituting each of these values for t into the equation to find your corresponding m value, or text messages in millions. Okay? All right. So when t equals 0, 95 million text messages were sent. Right? When t equals 1, 2015 million text messages. When t equals 2, we have 335 million text messages. In 2005, when t is 3, we have 455 million text messages. Right? Your text messages are your range. Okay? Your domain